You're all welcome to this morning class. Good morning, student. You're all welcome to this morning class. Okay. Good morning, everyone. You're all welcome to this morning class. How was your night? Hope you are fine. You're welcome once again. Yeah, this morning we'll be looking at trigonometry. And before we move further to do anything, we are going to know the meaning of trigonometry. Please like, share, and comment. It's very important. And don't forget to take the attendance. Okay. Here we have a definition. Trigonometry. When we say trigonometry, this is a branch of mathematics which deals with circular measures and trigonometrical functions as the ratios of the sides of a right angle triangle. That is talking about acute angles. So, in the case you are asked to define trigonometry, you give this definition, right? Are you following? Do you understand? Okay. So, let's proceed. Try and wake others who are still sleeping to be part of the class. Not clear, I think it's from where you are, the network, the environment you are. Here is clear. The environment you are. Shegun is not clear. Are you sure? Are you sure that it is not clear? How sure? It's not clear. Is it clear or it is not? It is clear now, right? We can proceed, right? Morning, Yusuf Bello, you're welcome. Okay, yeah, so this is the definition. Let me take it once again. This is a branch of mathematics which deals with circular measures and trigonometrical functions as the ratios of the sides of a right angle triangle. Acute angles, all in brackets, acute angles. So now, let's begin to explain all this mathematically. Amen. Let's have our right angle triangle. This is our right angle triangle, right? We can name here A, B, and C, right? This is A. Okay, let's forget about this. We assume here to be Y, X, and R. True of us. True of us is true, right? Okay. So if you agree with me, let's recall back to our secondary school days. Recall back to our secondary school days. What do you mean by SOHCAHTOA? Amen? Yeah. Let's go by this. SOHCAHTOA. SOHCAHTOA. Okay? So, if you agree with me, let's define so. So means S sine theta, right? Then here is opposite. Here is hypotenuse. Then here is adjacent. True or false? It's true, right? So if you agree with me, it means sine theta is equals to opposite all over hypotenuse, opposite all over what? Hypotenuse. True or false? Then this is equals to what? Opposite is y all over hypotenuse is r. True or false? True or false? It's true, right? Do you agree with me? Okay. So, please like. You agree with me, right? Okay. Then, let's consider car. Car. This means cos theta. Cos theta, which is equals to A means adjacent. Then H means hypotenuse. Amen. Then this is equals to adjacent is what? Adjacent is X. Then hypotenuse is R. Amen. Okay. Then TOA. T means tan theta. Tan theta, which is equals to O means opposite. Then A means what? Adjacent, right? Okay. Then opposite is what? Y. Adjacent is all over X. True or false? Okay. So it implies that. Note that tan theta is the same thing as what? Sin theta all over what? Cos theta. True or false? It's true, right? So as you can see, our tan theta is equals to the same thing as what? Sin theta all over cos theta. Amen. Then this is equals to what is our sin theta? Sin theta is y all over r. Then divide what is cos theta? Cos theta is x all over r. As you can see now, you don't need a prophet to tell you our tan theta is equals to, by the time you convert this to multiplication, y all over r times this r will come up, x will come down, right? All over x, this and this. You can now see that this is r x. You can now see that tan theta is the same thing as sin theta all over cos theta. Amen. Okay, hope you are following. Hope you are following, right? Okay. Any question before I proceed further? Because we are going to somewhere that will make use of all these things anytime soon. Okay, let's proceed. Let us proceed. Amen. Okay. So let us move further to consider what of sec theta. Sec theta is what? 1 all over 1 all over what? Tan theta, right? True or false? So if it is like this, it means 1 all over what is our cot. We're referring to cot. Cot theta is equals to 1 all over tan theta. Then this is equals to our tan theta is what? Tan theta is 1 all over tan theta is y all over x. Then by the time we cot theta, we turn it. Okay, let's do it for the sake of manuals. Then this is the same as 1 times x all over y. True or false? True or false? It's true, right? So it means our cot theta is equals to x all over y, isn't it? Isn't it? Do you agree with me? Oh, sorry about that. The camera is blurring. I think the network is from where you are. Yeah, there's nothing like that. The network is from where you are. You agree with me, right? Okay. So then what is cosec theta? Cosec theta is what? 1 all over sin theta, right? Am I right? Cosec theta will give us 1 all over sin theta. Am I right? Look at the board. Am I right? Am I right? Yes or no? Yeah, I'm right. So what is sin theta? Sin theta is y all over r. So it means our cosec theta now be equals to 1 divide y all over r. Amen. Then this is equals to 1 times r all over y. It means our cosec theta is equals to what? Is equals to r all over y. Yeah. You agree with me, right? Then sec theta. Sec theta is equals to what? 1 all over cos theta. Then this is equals to, what is our cos theta? Our cos theta here, look at it, cos theta here is x all over what? R. Then this is equals to 1 divide x all over r. Then our sec theta will now be equals to 1, convert this division to multiplication, r all over x. Therefore, our r all over x. It implies that sec theta is equals to r all over x. True or false? Look at the board very well. True or false? It's true, right? Okay. hope I'm right. Can you see the board clearly? Okay. Yeah. So let us make progress. You agree up to here. So now let us let's consider some examples. Let us consider some examples. Yeah. If you agree with me, let's consider some examples. Yeah. Okay. One of the examples is if cos x equals to -41. Example, if cos x equals to 9/41, determine the value of the other, determine the value of the other 5 trigonometrical ratios. Okay. Yeah. So let's look at this question first. Let's consider this example. If cos x equals to 9/41, determine the values of the other 5 trigonometrical ratios. So let's proceed to consider this. Okay. So this particular question, we can use so many methods to evaluate this particular question. It's simple as ABC. Either you approach it this way or you use Pythagorean theorem to approach it. They said we should find, if cos is given as this, find the other 5 trigonometrical ratios. It means they are talking about already your cos has been given 1, sin, tan, cot, cosec, and sec theta. That is what they are telling us to find. It's simple as ABC. So let's look at it together. let us write a solution. If we write solution, it means our cos x is equals to 9 all over 41. Amen? Okay, so here we'll be using, please take note of all this because we are going to make use of them anytime soon. So here we'll be using this diagram. Yeah, we'll be using this diagram. It's very important. Make sure you draw the diagram. Very, very important. Okay. We'll be using this diagram. Yeah. So this is opposite. This is opposite. Okay. Adjacent. So now here our cos theta is what? Adjacent all over what? Hypotenuse. Two of us. So here will be 9. Then here will be what? Because car. So this implies that what? Car. So it means cos theta is equals to adjacent all over what? Hypotenuse, isn't it? So let's just assume this angle to be A, B, and C. This right angle triangle. Two of us. Okay. So I mentioned to you that we can use so many methods to solve this problem. But the method I want to use now is I want to apply Pythagoras theorem here. If you can see what I am saying, to obtain this other side so that we can easily make use of the trigonometrical ratios. Is that clear? Do you understand? Okay. So if you agree with me, let us proceed further. Let's proceed. So how can we obtain this opposite? We now apply by Pythagoras theorem. By Pythagoras theorem. Pythagoras is talking about this rectangle triangle. Said the square of the longest side is equal to the sum of the square of the two remaining sides, two of us. So that is, it means either x squared plus y squared, that is, we assume this one to be y, x, and r, is equal to r squared. That is the mathematical statement of the Pythagoras theorem. So here our y is unknown, r is equal to 41, x is equal to what? 9, two of us. So here will now be 9 squared plus y squared equals to 41 squared. Yeah, I need an answer. So by the time you take this one to the right hand side, y squared will now be equal to 41 squared minus 9 squared. So somebody should work this one out very fast, please. I'm waiting. I'll give you 1 mark. Very fast. Just 1 minute. Under 1 minute, I'll give you 1 mark. Very fast. The first 2 students, I'm going to give you 1 mark. Oh, Ebukwe Chibijo, 1,600, right? Okay, please. And Unasa, 1,600, cool? It's okay. Let us proceed. $1,600, right? So it means here y equals to 1,600, right? So we take the square root. What is the square root of 1,600? Take the square root and tell us. What is the square root? Is it 42 or 40? So the square root of y will be equal to what? 40. True or false? So it means here is 40, right? So now let's move further to consider the 5 other trigonometrical ratios. So it means we can now say sine theta, and sine theta is what? We are using SOHCAHTOA. We are using SOHCAHTOA, so sine theta should be what? Sine theta should be opposite all over what? Hypotenuse. True or false? So opposite is 40, all over hypotenuse is 41. Am I right? True or false? True or false? It's true, right? Okay. Then let's clean this side. Let's clean here, but we are coming back to make use of all this. So please take note of all these things I'm cleaning. Okay. Yeah. So let's proceed. Okay. Okay. I think we can make use of here. Sin theta, then tan theta should be what? Opposite all over what? Adjacent. Opposite is what? 40 all over 9. True or false? Then cot theta is what? 1 all over tan theta. True or false? Am I right? So cot theta should be 1 all over 40 all over 9. Hope I'm right. Look at the board. Look at the board. Look at the board very well. So it means after everything, our cot theta now be equals to 9 all over what? 40. Okay? Then let's move further to consider cosec theta. Cosec theta is what? 1 all over sin theta, right? This is equals, what is our sin theta? So here will now be 1 all over 40 all over 41. Then cosec theta now be equals to 41 all over 40. True or false? Then sec theta now is equal to what? 1 all over cos theta. Then cos theta is given as, this is theta, not x. Change it to theta, please. Sorry about that. So cos theta is equals to what? 1 all over 9 all over 41. True or false? So here will now be our sec theta is equals to 41 all over 9. So I think we are okay. 1, 2, 3, 4, and 5. This is what they asked us to find. Any question? Please look at the board very well. There is any question I want you to ask. Any question? Please share the link on your Facebook wall, TikTok, Instagram. Share the link. Okay. Hope you are copying the notes. It's very important to. Okay, so we can proceed, right? It means we are done with one example. Okay, let me clean all this. Then proceed further. Sine and cosine rule. Let us have this, right? So name here A, B, C. This is small letter A, small letter C, small letter B. So here our sine A all over sine B, right, is equals to, sorry, small letter A all over sine A is equals to small letter B all over sine B equals to small letter C all over what? Sine C, right? Hope you are seeing the board. Okay. So this implies that these rules may be used only when one side and any two angles are initially given, or two sides and an angle, not the included angle, are initially given. Then our cosine rule. This is sine rule, right? This is sine rule, right? This is sine rule. Sine rule. Then cosine rule. Cosine rule is if we have a squared, this is equals to what? B squared plus C squared minus 2BC times cos what? A, right? Hope I'm right. True or false? That is cosine rule. True or false? Then if it is B squared, or if it is B, or B squared is equals to A squared plus C squared minus 2AC cos B. Amen. Then or our small letter C squared is equals to A squared plus B squared minus 2AB cos C. So take note, depends on the this thing given. Okay. So the rule may be used only when two sides and the included angle are initially given, or three sides are initially given. Then the area of any right angle is area of any right angle is given as half times base times we call it, some people call it height, but perpendicular height, perpendicular height. Yeah. So we should take note of all these formula. Anytime soon can make use of them. So take note of all this. Amen. Amen. So as it is, we'll now proceed further to solve some problems that will help you. Okay. Please share the link so we can proceed, right, to consider some problems. Yeah. area of any triangle or half times AB sine C, or half times AC sine B, or sorry, let me bring this. Or half times CB sine A, right? Or square root of S open bracket S minus A times S minus C, B times S minus C. Yeah, I'm not mistaken. Then where our S is equals to A plus B plus C all over 2, right? Yeah. So let's take note of all these formulas, because anytime soon we'll make use of them. Okay, so let's move further to consider some problems. Yeah, let us move further to consider some problems. Yeah, in a triangle ABC, example, in a triangle ABC, angle A is equals to 51 degree, angle B is equals to 67 degree. Yeah, left and right is equals to 67 degree, and angle AB, AC, angle AC equals to 15.2 cm. Yeah. It says solve the triangle and find its area. Solve the triangle and find its area. Okay. Look at the board, everybody. Everybody should look at the board. So first thing, we are going to draw angle. Let us draw it. Okay. Okay. Let me just say solution. This is A. This is B. This is C. So angle A is 51 degree. Then angle B is angle A is 51 degree. Angle B is 67 degree, right? Okay. But mind you, know that angle C is unknown, two of us. So how can we find angle C? Since what we are going to do for us to obtain our angle C, it means C will now be equals to 180 minus angle A. 180 minus angle A, that is 51 degree, minus 67. So what is the answer? Somebody should write down the answer for us. What is the answer? What is the answer? Destiny, Francis. The answer is what? 62, right? 62 degree, right? So it means here is 62 degree. Let me write it. So our C is equals to 62 degree. Yeah. Okay, so far so good. So let's look at the board. They said we should solve the triangle and find its area. So what we need to do here, this is, mind you, this is our small letter C, small letter B, then our small letter A. Two of us. Look at the board very well. Look at it. So it implies that we need to find our small letter A, B, and C. Two of us, because it says find the triangle. So let's move further to find the triangle. Let's move further to find the triangle. So we need to find our let's find the triangle. Okay. So far so good. Look at the board. If we want to consider A, here our A. Yeah. Look at the board very well. Look at the board very well. Everybody should look at the board. How can we obtain either A or B? Just look at the board very well. And somebody should tell us, how can we obtain A or B? How can we obtain A or B? Yeah, here it stated that our angle AC is equal to 15.2 cm. It means here AC. So here is what? 15.2 cm. So it will be easier for us to obtain our A. So our A all over sine A is equals to B all over sine B. Two of us. So here will be A all over, what is our sine A? Sorry, our angle A is sine 51 degree equals to B is given as what? Look at it, AC, which is our AC, right? Is given as 15.2 cm, then all over sine angle B is 67 degree, right? So we cross multiply. Oh yeah, somebody should do that very quickly. Somebody should do that to obtain our A. Somebody should do that. Somebody should do that. I'm waiting for you guys. So consider this problem. A all over sine 51 degree equals to 15.2 cm all over sine 67 degree. Nobody is working. A equals to 12 points. Now few 12.8, right? Now few A equals to 12.8. Are you sure? Yeah? Are you sure? Do it again. Who is helping us? 12.8. That is A, right? This one times this. It means here will be A sine 67 degree equals to 15.2 times 51 degree. This is A. So somebody should press sine 67 degree. What is sine 67 degree? Sine 67 degree is what? Somebody should press sine 67 degree. Sine 67 degree. Sine 67 degree will give you 0.8205. A open bracket 0.9205. Then what is sine 51 degree? Press sine 51 degree. Sine 51 degree. Sine 51 degree. Sine 51 degree 0.777. Okay? 0.777. Okay? Then here will be 0.9205 equals to 5a. Sorry, a equals to, use 15.2 times 0.77. 15.2 times 0.77. The answer, please, somebody should work it out. 15.2 times 0.777. What is the answer? 11.81. Are you sure? 15.2 times 0.77. 11.8101. 11.8104, right? Okay, so we divide through by this. Our A will be equals to 11.8104 all over 0.9205. Okay, somebody should do this division. This somebody should help us. Somebody should help us. Divide it. 11.8104 divide 0.9205. What is the answer? 12.83. 12.83. 12.83 equals to 12.83. It means our A is equals to 12.83. Then that is our A. I hope we are right. $12.83, right? $12.83, right? Okay. Then what is left? Our A here is 12.83. Then here, let's work out here. Now we use this, so it means 15.2 all over sine 67 degree equals to C all over sine C, which is what, 62 degree. Am I right? Oh yeah, somebody should help us out. 15.2 times sine 62 degree equals to C open bracket sine 67 degrees. Right? So, what is sine 62 degrees? Somebody should help us. This one already sine 67 degrees. Sine 67 degrees give us what? 0.9205, right? 0.9205. So somebody should help us with sine 62 degrees, please. Somebody should help us with sine 62 degrees. Kayode, are you sure? Are you sure? 0.8 0.882, okay? 0.882 is okay. 0.882. .882. Okay, yeah. You divide, it means your C will now be equals to, use 15.2 to multiply 0.882, then divide 2 by 0.9205. 15 times 15.2 times 0.882. Please, fast, what is the answer? Let's try and finish it. Somebody should help us. 13.244. 13.244. Okay. 13.244. 13.244 divide 0.9205. Somebody should help us very fast. Yes. Is it 13.406? 13.406, sorry. .406. Am I right? If you multiply, this is what it will give you, right? 13.406. Am I right? Huh? Am I right? If you use 15.2 to multiply 0.882, it will give you what? 13.40. So the answer will be what? 14 point what? 14.56, right? 14.56. So our C is equals to 14. Let's just say 6 here. Then this one too, we'll just leave it since it is in one decimal place. So here is so here is 14.6 here. Okay, so now let's proceed to consider the area. They said we should find the area. So it means we can use any of this, either this or this. So whichever one you want to use. So the area, let's consider the area now, because either 1 all over to AB sine C. So here will be 1 all over our A is 12.8 times what is our B? B is 15.2 times sine C. Sine C always is sine 62 degree. I think I'm right. Am I right? Okay, gentlemen and ladies, thank you for your time. Our time is up. Let's welcome calculus students. Make sure you take note of this. I think in our next class we will prove identities. Is that clear? And do some other examples. Are you following? Please don't forget to share, like, comment. Be very grateful. Okay. Good morning. How are you? How was your night? You are welcome to calculus class this morning. Sorry for taking your time. You are all welcome. Okay. So this morning we'll be talking about integration. We'll be talking about integration this morning. Yeah, this morning we'll be talking about integration. Sorry. Integration. When we say integration, integration is the opposite of differentiation. Am I right? Are you following? Integration is the opposite. Yeah, my night was fine. And then is the opposite of differentiation. So now, let us define integration mathematically. Amen? Let's define integration mathematically. Let us have a function. Assuming we are asked to evaluate integral ax raised to power n dx. Amen? I want to define integration mathematically. That is, what do I mean by mathematically? Is we want to consider the formula. Is that clear? Okay. So now, if we are asked to integrate this function, it means, let's write solution. It means our integral sorry, our integral ax raised to the power n dx means, in differentiation, we still make use of this, true or false. So that's why they said integration is the opposite of differentiation. What do we have here? N, true or false? So it means you use this n to divide this function, then raise to the power of plus 1. So plus 1. Is that clear? That is, integration means ax raised to the power of n plus 1 all over what? N plus 1 plus any constant. That is integration for you. Plus any constant. It means it could be A, it could be B, it could be C, any constant. So this is the formula for integration. Take notes. This is the formula for integration. Any question before we proceed? You have any question? Please, have any question? Ask. No question, we proceed. Any question? Yes or no? Do you have any question? No question? Okay. It is not clear how. I said if you are asked to integrate any function, what do we have here? We have ax raised to the power of n dx, true or false? So now, here will now be a raised to the power of n, ax raised to the power of n plus 1 divided by what you have added, n plus 1, plus any constant. Not necessarily b. Here somebody can use k, or somebody can use c, or somebody can use d, or somebody can use a. Is that clear? Any alphabet. Do you understand? Do you understand? So let us fix idea with example. So now here, let's say evaluate integral 2x raised to power 2 dx. So how can we evaluate this? Let's look at the board together. Right solution, our integral 2x raised to power 2 dx. So you can now see that, compare this and this. Here we have a, we have x. Here we have 2, we have x. Then here we have n, we have 2 dx. True or false? It's true. So now we want to transform it in this form. So what do? We now write 2x raised to the power of your n is what? 2 plus 1. Amen. Then all over 2 plus 1 plus any constant. It could be B, C, D, M, Y, or any alphabet. Is that clear? So can you see now? So as long as integration is concerned, you must put this is the formula, the back of your mind, anywhere you are, as long as integration is concerned, calculus is concerned too. Is that clear? So now, can you see now, we have transformed this function into this form. Do you agree with me? So it means this is equals 2x, 2 plus 1, 3, all over 3 plus b. Any question? Please look at the board carefully. If you have any question, ask. Any question? Do you have any question? Any question? Danzuma, Shepherd, do you have any question? Yes or no? So can we proceed? Okay, let's proceed to consider more examples. Amen. Let us proceed to consider more examples. Okay, I want us to note that integral dx, if you are to integrate dx, whenever you integrate dx, you will have x plus a constant, either k or any alphabet. Take note. Do you understand? Take note of this. If you are to integrate sine x dx, you have minus cos x plus any constant. If you are to integrate cos x dx, you have sine x plus any constant. Amen. Are you following? If you are to integrate 1 all over x dx, you are going to have in x plus any constant. Please take note. Do you agree with me? Look at the board very well. Take notes. Hope you are following. Take note. Yeah, I can see Agric, Peculiar, Daniel. You can see Chemical, no Electrical. I think those boys are bigger boys. They don't want to learn. Electrical, very unserious set of students. I'm not seeing them here. So unfortunate that I'm not seeing them here. I'm not seeing electrical here. I can see chemical, agric. Okay. So take note of all this. Likewise, if you are to integrate, sine a x dx, we are supposed to have minus 1 all over a cos ax plus any constant. Take note. If you are to integrate cos ax dx, this is equals to 1 all over a sine ax plus any constant. Take note. If you are to integrate exponential ax dx. This is the same. This is equals to 1 all over a exponential ax plus any constant. Take note of all these things because it will do you good. This will do you good. Electrical, I'm seeing only one person. Yeah, India. You are welcome. This person from India. You are welcome to this morning class. Thanks for watching me. You are welcome. I'm very grateful. Okay. So, far so good. So take note. If you are to differentiate cosec square a x dx, if you are to integrate cosec square ax dx, suppose to have minus 1 all over a cot ax plus any constant Take note. Is that clear? If you are to integrate sec square ax dx, this is equals to 1 all over a tan ax plus k. Amen. Take note of all this. If you are to integrate sec ax tan ax, if you are to integrate sec ax tan ax dx, this is equals to 1 all over sec tan ax sec ax plus any constant. Take note of this. That clear? Then, if you are to integrate cosec ax cot ax, you have to integrate cosec ax cot ax dx. This is equals to 1 all over cosec ax plus k. Take note. Take note. So you should take note of all this. So take note of all this. So we can proceed, right? Yeah, the man from India, I love you too. I love you too. Okay, so let's proceed to consider some examples. So take note of all this. Okay, we now know that if we are to evaluate integral 5x raised to power 2 dx, it means this is what we are going to have, true or false. Using the formula, it means 5x raised to the power of 2 plus 1 all over 2 plus 1 plus any constant. Amen? Then this is equals to 5x raised to the power of 3 all over what? 3 plus b. True or false? True or false? It's true. Okay. Now let us consider linear functions. Linear functions. Let's consider linear functions. Amen? Okay? Okay, let's evaluate integral 2x plus 1 dx. Whenever you come across this, let's write solution. Our integral 2x plus 1 dx, this is equals, what we need to do is we are going to use the integral to multiply the function. It means we can rewrite this function in this form. Integral, this is equals to integral 2x dx, then plus integral 1 dx. So it means this and this, they are all the same thing. So we are just going to use the formula. But mind you, we can still rewrite this one here. But you know, even if you don't write 1, everybody knows that 1 exists here, true or false. So it's not necessary. But let me just write it down. So this implies that we apply the formula, right? Already we have invisible 1 here. So here will be 2x raised to the power of 1 plus 1 all over 1 plus 1, isn't it? Then plus 1 times dx is the same thing as dx, true or false? So it's not necessary. So if you integrate dx, what are you supposed to have? X, true or false? So here will be x plus any constant, either k or d or b. So the final answer will now be equals to 2x raised to the power of 2 all over 2 plus x plus k. Amen? Any question? These are linear functions. Any question? Any question? So we can proceed. Okay, Blessing said, no question. It means you are all following. So now you know how to integrate any given function, isn't it? Okay, favor to say we should. Let's proceed. Okay. So if we want us to proceed, then let us fix idea with one example. Let's fix idea with one example, right? I want to clean this. There's no question. Evaluate integral 4 minus 7 all over 3x. Is simple as ABC. Amen. When you come across questions like this, everybody should look at the board. Our integral 4 minus 7x all over 3 close bracket the x. Let's transform it the other way. It means integral 4 dx. What do we have here? Minus integral 7x all over 3 dx. It means this and this, they are all the same thing. Do you understand? You agree with me? So if you agree with me, this is equals to, this is a constant, we can factor it out, we can bring 4 out from the integral to have it in this form so that it will be easier for you to integrate. Then here we have a constant 7 all over 3. Two of us will bring it out 7 all over 3 so that it will be easier. So here we have x dx. Two of us, do you have any question at this point? Please ask. Drop your question. Let me give you 1 minute to ask question. Or we proceed. There is no question, we proceed. No question? I'm not saying electrical students. Can't see any electrical student. Oh, you don't understand. Blessing. Okay. I said as it is. When we have functions of this form like this, what you need to do first, it will be easier for you. Okay, let's have it in this form. Assuming we have integral a plus bx close bracket. So what you need to do is use this dx and this integral to multiply out these brackets. So now we have a here. So if you do that, it means we use this and this to multiply a. We are going to have a dx. Blessing. Are you listening? Then what we have here? Plus the same thing applicable. Use this dx and the integral to multiply bx. So integral, you first write the integral, then times bx dx. Do you understand? Blessing. So now we are going to do the same thing here. Look at it. Use this dx and the integral to multiply 4 here. So first write the integral, then 4 times dx. Can you see now? Then the same thing, what is here? Minus. Use this dx and the integral to multiply 7x all over 3. Write 7x all over 3. But first write the integral. Can you see now? Times dx. Do you agree with me? Blessing. Any other question? Any other question? Blessing. Are you following? Are you following? Do you agree with me? Blessing. Okay, so let's proceed. I'm seeing only one person electrical from electrical. Okay, so if you agree with me, then I now went further to say that I said 4ds, 4 is a constant. We can factor it out from the integral. So you can now see that we bring 4 out. Likewise, 7 all over 3 is a constant. We factor it out, 7 all over 3 out of the integral. Can you see now? So now it will be easier for us to integrate this function, amen, by using the formula. You can now see that here is 4. If you integrate the x, already you have written it down, two of us. If you integrate the x, it's going to give you what? X. Then minus 7 open bracket, 3 open brackets. Integrate x dx. If we apply the formula, mind you, there is an invisible one here, two of us. So here will be x raised to the power of 1 plus 1 all over 1 plus 1, close the bracket, plus any constant. It could be d or any alphabet. So can you see now? So 4 times x is 4x minus 7 all over 3 open bracket x raised to the power of 1 plus 1 is 2. 2 of us raised to the power 2 all over 1 plus 1, 2. Then plus the constant. If you don't put the constant, you are wrong. Is that clear? This constant shows that you've integrated this function. Do you agree with me? Okay. So now we can now multiply this. 3 times here will now be 4x minus 7 times x squared, 7x squared, all over 3 times 2, 6, plus d. So this is our final answer. Any question? If there's any question, please drop it in the comment section so that we'll look at it together. Amen. Do you have any question? Any question? Do you have any question? No question? Any question? There is no question. So we can proceed, right? Okay, let's proceed further to consider quadratic functions. Let us proceed further to consider quadratic functions. Amen. Quadratic functions. Is that clear? Let's consider quadratic functions. Let us consider quadratic functions. Let's consider quadratic functions. Okay. I want to look at quadratic functions. Right? Quadratic functions. Okay. You know, quadratic functions, we all know what quadratic is all about. Two of us. Okay. You know, quadratic functions are of this form: integral ax squared plus bx plus c dx. Amen. These are quadratic functions. Are you following? Are you following? These are quadratic functions. So you don't need a prophet to tell you. So if you want to evaluate this integral, it's the same approach. Amen? So what you need to do, the same thing, so that it will be easier for you. So we can part this integral in this form. Integral ax squared dx plus integral bx dx, then plus integral c dx. Two of us. It means this is the same thing as this. Two of us. Look at the board very well. Do you agree with me? Okay. So if you agree with me, it implies that a is a constant. We can still factor it out from the integral b and c. So let us factor it out. X squared dx plus b integral x dx, amen. Then plus c, factor it out, integral dx. Yeah. So can you see now? So let us integrate x squared. Here will now be a open bracket. If we integrate x squared, according to the formula, true or false? Yeah. So here will be x raised to the power of 2 plus 1 all over 2 plus 1, close bracket. What we have here? Plus, right? Plus b, open bracket, x here. Integrate x dx. We are going to have x raised to the power of 1 plus 1 all over 1 plus 1. True or false? Then what we have here? Plus c. If you integrate the x, what are you supposed to have? You're supposed to have x. And don't forget to put the constant, either g or any alphabet. Amen? Any question before we proceed? Please drop it in the comment section. If you have any question, please drop it. I'm not saying electrical students. I know they are bigger boys. They don't want to learn. I can see chemical, agric. Only chemical and agric. Electrical students are bigger boys. I love that. They are not ready to learn. That is nice. It's okay. After all, education is not by force. Yeah. So do you agree with me? Any question? No question. So I can proceed, right? Or we can proceed. It's okay. Don't forget to like, comment, share. Share it on your platform, either Facebook, TikTok, WhatsApp, X, and the rest. And I will be very grateful. Okay. If you agree with me, let's proceed. Amen. So here will now be equals to ax raised to the power 2 plus 1, 3 all over 3. Then plus bx raised to the power of 1 plus 1, 2 all over 2 plus c times x is cx, then plus the constant g. Is this difficult? I don't think. Except you were not in this class. So it means you always find it difficult. Any question, please ask your question. I'll be very grateful to answer your question. Any question? No question. If there is no question, let us proceed to solve more examples. Let's proceed to solve more examples. If there is no question. So now let us fix idea with examples like this. Let us fix idea with examples like this. Let's fix idea. Amen. Determine integral of 2x raised to power 3 minus 3x all over 4x dx. As simple as ABC. It is not difficult. Amen. It's very simple. Peter, Stephen, I think you are the only electrical student that is available here. Peter, Stephen. Okay, yeah. So when you come across functions of this form is simple as ABC. What you need to do is integral 2x raised to power 3 minus 3x all over 4x close bracket dx. I want us to think very fast. Amen. Go back to your elementary tree. When you have a x squared plus bx all over cx, we can still transform this in this form. Amen. This is the same thing as ax squared all over cx plus bx all over cx. I want to do something. Two of us. So it means this and this and this will cancel to give us ax all over c plus this will cancel to give us b all over c. Do you agree with me? Do you agree with me? I want to do something. That is why I'm using this one as an example. Do you agree with me? Okay. So if you agree with me, let's proceed. Let us proceed. This implies that it means this is the same thing as integral 2x raised to power 3 all over 4x minus 3x all over 4x. Amen. Dx. True or false? It's true. So, if you agree with me, if you can see what I am saying, it means let's part it, right? So this is the same thing as integral 2x raised to power 3 all over 4x dx. Then what we have here, minus 2 of us, integral 3x all over 4x dx, isn't it? True or false? It's true, right? Okay. So as you can see, 2x cubed and 4x, it can divide itself. True or false? So this is the same thing as 2 to itself, 1, 2 to 4, 2. X, 1. So here will now be x squared all over what? 2 dx minus integral, this and this will cancel. 2 of us. 3 all over 4. Sorry about the network. Very sorry about the network. Do you understand how we got up to that? I said, as I was saying, I said this is the same thing as this, two of us. Then we can now transform it in this form. Then we can see that 2 can divide itself 1, 2 to 4, 2. If we do it, transform it in this form, 2 to itself 1, 2 to 4, 2. Then x to x cubed is x squared dx minus x to x 3 all over dx, 3 all over 4 dx. True or false? So when you 1 all over 2 is a constant, we factor it out, we are going to have integral x squared dx minus 3 all over 4, also a constant, factor it out, then we'll be left with what? Inside the integral, we'll be left with what? Dx. Then when we integrate this, we are going to have 1 all over 2, open bracket, x raised to the power 2 plus 1, all over 2 plus 1, close bracket, minus integrate the x. Supposed to have x, then I told you that the constant is necessary. That's to show that you integrated this function. So plus the constant. So after everything, 2 plus 1 is 3. That is why you are saying x raised to the power 3 times 1 is x raised to the power 3. Then here we have 2. 2 plus 1, 3. So 2 times 3, 6 minus 3 times x. 3x all over 4 plus what? A. So if you have any question, please ask. If you have any question, ask. Do you have any question? So let's close with one example. Is that clear? Let us try and close with one example. It will do us good. Please, let us close with one example. Okay. Let's close with this example. It said, evaluate integral 1 minus t raised to the power of 2 dt. Amen? This one you are integrating with respect to t, not x. So take note. We are going to close, just exercise patience. We will close with this example. Is that clear? Exercise patience. Okay, so please like, comment, share your page. I'll be very grateful. Okay, so let's consider this. Let us write solution. Integral 1 minus t raised to the power 2 dt. Amen. Don't be scared of this. We can use substitution, but we don't want to use substitution. We want to integrate this function direct. So now I want to ask us, I want to refer us back to our elementary mathematics. When you have a plus b all in square, what does it mean? It means that this is the same as a plus b times a plus b. True or false? It's true, right? Okay. So now, if we have this, so let us write. Note that 1 minus t all in square is the same thing as 1 minus t times 1 minus what? T. Amen. So let us multiply. 1 times 1 is 1. 1 times minus t, right? Minus t times 1 minus t. Minus t times minus t plus t squared. True or false? So this will give us 1 minus t minus 2t plus t squared. True or false? Look at the board. Amen. True or false? It's true, right? Okay. So if you agree with me, this implies that this is equals to, instead of this, we are going to write this. So integral, open bracket, 1 minus 2t plus t squared dt. Then this is equals to the same thing applicable here, integral 1 dt minus integral 2t dt, then plus integral t squared dt. True or false? True or false? It's true. So this is equals to 1 is not necessary that we write 1. So we just write it dt minus, we can factor out 2. 2 is a constant. 2 t dt, then plus integral t squared dt. Amen. True or false? Look at the board. True or false? True, right? Okay. So if you agree with me, let us finish this problem. If you agree with me, if we integrate the t, what are you supposed to have? We are going to have t, then minus 2 open bracket, integrate t, here will be t raised to the power of 1 plus 1, all over 1 plus 1, true or false, according to the formula, then plus integrate t raised to the power 2, t raised to the power of 2 plus 1, all over 2 plus 1, then plus any constant. Amen. So here will now be t minus 2t, because t plus 2t is t squared, all over what? 2 plus t raised to the power 2 plus 1, 3, all over 3 plus k. So as you can see, with this and this we cancel. True or false? So the final answer will now be t minus t squared plus t raised to the power of 3 all over 3 plus k. This is where we are going to round up for today. Thank you so much for your time. I love you guys. I'm very grateful. I pray for God's wisdom upon you. Please don't forget to share, like, and comment. I'll be very grateful. Thank you. See you same time, same period next week, Saturday. I love you guys. Thank you. See you guys. Bye. Thank you very much.